Okay, so today, yesterday we were like expanding, like if you notice the pattern between the expansion, so you got two binomials. The binomials are like, if we expand the binomials, we get the standard form back, right? So today we're going to start in standard form and go to factored form with the process called factoring. That's how it works, right? So we're going to go standard form and we're going to factor standard form to get the factored form. And you expand factored form to get the standard. Okay.
Why are you repeating?
I don't know. I'm having a weird day.
It's a learning tactic.
Yeah.
Okay.
I will. I'm sorry.
So some stuff we're gonna like identify it or figure out. We're gonna use this man method, right? It's pretty common. Like you should have seen it at some point, right? So we need two numbers to multiply. So we're gonna identify which number it needs to multiply to. We're going to identify which number it has to add to, and then we're going to identify what the actual two numbers are that satisfy those two conditions. That's the whole goal today. And then we can check our answers using expansion to see if we got it right or wrong. Okay, so we'll do all that today. Okay, so just a quick recap. Standard form is written y equals ax squared plus bx plus c. Factored form is going to look like ax minus s, x minus t, right? S and t are just numbers. Whatever those numbers are, we'll call those are the factors, right? And then vertex form, we had y equals ax minus h squared plus q or k. Okay. Okay. So the first thing you want to check, which we did yesterday, and we'll see a couple examples of this today, of where it makes it easier, is we always want to check to see if we can find like the greatest common factor. Yeah, Noah.
What's the in factor form? What's that like? Number beside or letter beside x in the backwards.
There's an S and then there's T.
So that's
Yeah, they're just numbers. You could say like it could be anything really, M and N, whatever. They're just placeholders for some numbers, which turn out to be the factors, which we'll see today. Okay. So you're always going to try and like factor by finding the greatest common factor, right? So we'll call that common factoring. By finding, okay, so the greatest common factor. So we're always going to start with that, right? Okay. And what are we doing today? I'm going to say trinomial. Trinomial, the prefix tri means 3, right? That's where we're starting, trinomial factoring, okay? And then we got 3 kinds. So this is like it's a precursor, right? So we're going to see 3 kinds of factoring, okay? We'll probably take 3 days to do this, maybe 2, okay? Today we'll concentrate on what I call simple trinomials. Right? That's when the a value equals 1, right? Then probably tomorrow we'll concentrate on the other 2. Okay, so tomorrow we're going to concentrate on their formal name. I'll write down their formal name first. We'll call it the complex trinomials, which I like to call tricky tries, right? That's when the A value isn't 1. Okay. And then the last one, which we'll probably get to tomorrow, will be difference of squares. Which is hard to see sometimes, the difference of squares, but it's the easiest factoring method, aside from common factoring. It's the easiest of those three. Okay. So this is recap. Some of you are like really easy, right? But we'll start at the base and see what happens, right? So here's how I would attack. So you got three different questions here. We'll start with the first one. And I'd be interested to know, it's kind of like we'll call this a game initially, is I've got these conditions. I need them to sum or add to this, and I had the product is the M piece, right? So they need to multiply to 36 and add to 15, okay? Or add to 15 and multiply to 36. So what's going to be your approach, I guess, is my question, right? So you're going to go, okay, well, you're going to try and find the two numbers that satisfy that. Which might be easy right off the bat, might not be, I don't know. Okay. Do we know what the two numbers are straight away, Noah?
I think 12 and 3.
Okay, 12 and 3 works. Okay. Now, I'll show you the method. We'll just go with this for now, right? So we're going to say 12 and 3 are the two numbers that satisfy that condition, those two conditions. What was your thought process, Noah, with that? What did you try? Like, and so I guess like I'm checking. Like, did you find two numbers that added first, or did you find two numbers that multiplied first? Okay, so I always check like, let's check the multiplying first, and this will be the same thing for the tricky trinomials tomorrow, right? For the complex, check the multiplying first. And then you check to see if they added, right? Okay. So with the second one, let's do the second one now. I need two numbers that are going to multiply to negative 18, right? But then add to negative 3. Hector?
Positive 3 and negative 6. Or am I bad at math? Like the math.
Positive. You can write them down, right? And then you're like, so that like it's okay to write them down. So you said positive 3 and negative 6, right? And then like that's fine. And then you're gonna go, okay, well, what's 3 minus 6? Negative 3. So that's good, right? Always check the multiply. Like 3 times 6 equals 18, right? If you throw a negative on one of them, then that works. That's good, right? Then you're like, okay, we've got to add them together. So negative 6 plus 3 or 3 minus 6, they both land you on the negative 3. So it's good. We know we're good. So those are the two factors. Okay. And what about 12 and negative 7? So we need two numbers that are going to multiply to 12, but add to negative 7. So why don't we take the opportunity to look at this one? So let's just start here. Okay, so this is how I would attack every one of these. I would do this every single time. I'm going to check the multiplying, right? I'm going to go, okay, 1 times 12. Well, that equals 12, so that's good, right? Takes care of the multiplying. But 1 plus 12, 1 minus 12, 12 minus 1, like none of that is ever going to equal negative 7. So they're like, okay, we're done. Like it's not going to work. So let's go to the next one. So I'm going to go from 1, I'm going to go to 2. 2 times what gives me 12? 6, right?
I just switched to
Hey, come on. That's
Do I show you it? Or?
No, you're okay, buddy. Okay, you caught up after.
Can I sit at the back or is...
Yeah, it's okay. Okay. 2 and 6 is 8, right? There is no combination of 2 and 6 that's going to give you 7. Negative 7. It's okay. Not going to work. Next one. I went from 2 to 3. I'm just counting down. I'm like, okay, well, what's the next multiple? 3 times what gives me 12? 4. 3 plus 4 gives me 7, but I need it to be negative 7. So that's a problem. But there's nothing wrong with going, okay, well, both of them are negative. Negative 3 times negative 4 gives me positive 12. And if I were to add them together, I'd get negative 7. So there you go. That also takes care of that. So then your factors are just negative 3 and negative 7. Make sense? So those are just, you're kind of like, there's your man method. Multiply, add, tell me the two numbers that make those, that satisfy those two conditions, the M and A piece, right? It's good? Okay. So we go down here. We've got our quadratic written in factored form. Okay. Let's just review some expansion quickly. Okay. Expansion work is going to be like where you're doing your distribution of your FOIL stuff, right? So I'm going to see x, I'm just going to do this, my distribution work, right? So I'm going to see x squared plus 7x plus 3x plus 21. And then I'm going to collect the 2 in the middle. Okay, so all I did there was collect the like terms in the middle. Okay, at which point you're going, okay, do we see, how about we do this whole table and then I'll ask you the pattern. Okay, let's do the next one. It's going to do the same thing. So x squared plus 4x plus 5x plus 20. So that's going to condense to x squared plus 9x plus 20. Okay. So I'm just expanding, right? I'm just doing the distribution, or you could do the tables or whatever, right? The point is I'm going to show you the pattern between the two in a sec. Okay. So this one here is going to be y squared to change the variable. Y squared minus 2y plus 6y minus 12. You collect the 2 in the middle. That's going to be y squared plus 4y minus 12. Okay. You should have four multiples, right? So you're going to get four terms with 2 binomials that you're multiplying together. And then you should get, in those 4 terms, 2 that are like terms that you can add together to create the trinomial. Okay. Now my question is, now that we've done that, this is me going, we're going from left to right. What is this process called? It's expansion. It's expansion with an S or an T? I'm horrible at this.
Great question.
I have no idea.
It's spelled with an S here, but I don't know.
I could have spelled it wrong. I don't know. Okay. So that's expanding. I should just write expanding. And then what would this process be called then? Factoring.
Did you say backwards expand?
Backwards expanding.
Factoring.
Oh, okay.
Backwards Expand.
He keeps making it easier for you.
Okay. So, my question is, do we see any relationship between the expanded form and the factored form? Look, if I gave you a jumble of these things, like if these were all mixed up, the order of these ones here, if I jumbled these, would you be able to match them with their corresponding factored form over on the left, is my question. How would you do that? Right? That's the relationship I'm looking for you to get. Right, Hector?
How would you do that?
Yeah, I'm just like, do you see a pattern between this
Yeah,
here
for sure.
and this here?
Well, if you took the two things and plugged them in, like at least I think that's how you do it. Maybe I'm wrong, but I'm struggling to explain what I mean here. But
You plug them in.
Isn't 7 and 3 the like what it is? It's the two. They're called factors, but like they are the actual factors. The 7 and the 3.
Yeah.
So couldn't you take them and
What does 7 and 3 multiply to?
21?
The number on the end, right? And then what do they add to?
Oh.
I don't know how to talk, but that's what I was trying to say.
Oh, yes.
Right? We see that? The whole time. Every single time. Right? 4 and 5 multiply to 20. 4 and 5 add to 9. Six and negative 2 multiply to negative 12. 6 and negative 2 add to positive 4. Alright. So we okay? Same pattern over and over again. Okay, so if we look at this, this is just standard form, right? I've got y equals ax squared plus bx plus c. Or I've got an a floating here where it's 1, right? So I've got my a, b's, and c's, right? And we need two numbers that multiply to c. In this case, 36, and add to b. Sure. So determine the pairs of numbers that multiply to 36. That's what's going to go in the box. These are what's called factors. Add to 15. Right? Let's do the work inside this, in between the spaces. Right? So we're going to go, okay, well, we need to multiply to 36. Add to 15. What are those two numbers? We said were 12 and 3. So here's the nice part. Here's the nice part about simple trinomials, okay? There's nothing else to do here, right? The tricky tries, or like the complex trinomials, those are going to be harder because there's something else going on there. But these ones, you physically, if this is a 1 here, if there's a 1 out front, it's a simple trinomial. As soon as you get these two numbers, you take their sign, you put them in the brackets. That's it. Question's over. That's factored form. If this is a 1 out front, when you find these two numbers, you throw the variable in front and the question's over. Right? That's this down here. But the sign has to go with it. So if it's negative, you got to put the negative in. If that was negative 12 and negative 3, then it would turn into x minus 12, x minus 3. take whatever the signs are, right? Put them right in there. That's it. And then you're done. No thinking at all. Just find the two numbers, throw the signs on them, right in the brackets, done. Okay. Everybody okay? So, let's do these practice questions. Okay. So I'm going to need two numbers to multiply. So this is like the man method that I say. We basically spell man backwards on top of the trinomial. So you need to multiply there, add, and you need to come up with the two numbers. Right? So we need to multiply to 20, add to 9. What are those two numbers? 5 and 4, right? So we should be at the stage almost, like, or you should get to the stage where you could, like, especially the positive ones, where we can, like, just quickly identify them. Unless they're really big. Like, the big ones are harder, right? Those ones you got to write out. But stuff for, like, anything lower than, like, 36 or something, like, we should be able to, like, know our multiplication table and figure it out, right? So for this one, I know, like, 5 times 4 is 20. 5 plus 4 is also 9. Right? So there are my two numbers. They're both positive, right? And then I just throw the variable in front. It's the variable x. So this turns into x plus 5 multiplied by x plus 4. Okay. If I were to check this, I'll only do this one time. I'll check it in red. X times x will be x squared plus 4x plus 5x plus 20. That matches that. I know I've done it right. Okay. I'm checking with expanding, but I'm factoring to get it into factored form. Okay, do the next one. So for this one, we need to multiply to 6, add to 7. What do we get? So remember, when you're checking, just start at the easy one. 1 times what gives me 6? 6. That's nice. 1 plus 6 equals 7. That's a nice one. They're both positive, right? That confirms this, both these conditions. So then once I've confirmed both those conditions, now we're able to go x plus 1, x plus 6. Done. Okay, next one might require a little bit more thinking, depending on how well you know your multiplication tables. Okay, also there's some negatives in there now, so that throws a wrench in it, right? I need two numbers to multiply to negative 40. Add to negative 3. Right. Yes, Hector?
Oh, do you want us to answer it?
You can, yeah.
Okay. Well, since you're working with a negative, first what you'd want to do is figure out like what times what equals 40.
Right.
And 5 times 8 equals 40. But since it's negative 40, you know one of the numbers is going to have a negative, and then you check to see. Like 8 minus 5 doesn't equal negative 3, so it's going to be 5 minus 8. So you're going to have your factors as x minus x plus 5, x minus 8.
Okay, did we catch that? So when you look at this, disregard the negative from the beginning, okay? Like pretend they're not here, okay? particularly on the multiplying one. So you're thinking, okay, I just need to find the two numbers that's multiply to 40, right? Then you're like, okay, well, 5 and 8 multiply to 40, so that's good. But then I'm like, okay, well, they have to multiply to negative 40, which means one of them is going to have to be negative, right? So then you're like, okay, well, which one is it, right? Because it also has to add to negative 3. So Hector was saying, okay, well, if the 5's negative, negative 5 plus 8 is going to be positive 3. That does not check out with the minus that's sitting there. Right, so I'm like, okay, well, then there's only other one option, right? You're like, okay, well, it won't be, the 5 won't be negative, the 8 will be negative. So you're like, okay, well, that checks everything off, right? 5 times negative 8 gives me negative 40, and if I add 5 to negative 8, I also get negative 3. At which point I'm able just to go like this. Let's say x plus 5 multiplied by x minus 8. Okay? So we'll do the last one here. I need two numbers to multiply to 36. Add to 20. Let's find those two numbers that satisfy those. What are they? Aiden? 36 and 2.
You want E?
On D, yeah.
Yeah, it's not good. 18 and 2, sorry.
Yeah, but that's good. Yeah, yeah.
Sorry, I read it wrong.
No, that's okay. 18 and 2. Okay? So then you're like, okay, both positive. Okay? We'll just throw the variable in front and be done. X plus 18. X plus 2. Done. Okay? Okay? So, what we will learn tomorrow will be, for the complex trinomials, okay, we'll do questions tomorrow, so don't worry about this, but the idea for today is that we want to deal with simple ones, right? You technically, when you find the multiple, anytime you're multiplying or finding the m in man, it's always the a value multiplied by the c value. Just with simple trinomials, what's the a value with simple trinomials? 1. So a times c is simple trinomials is 1 times the c value, so it's always just the c value, right? But with complex ones, a times c for this question would be like, that would be 6 times negative 30, which would equal negative 180. And then you'd have to find the two numbers that met at 24. That's a lot harder. Why would you do that when you could apply what we did yesterday? I can take the 6 out and write what's left. Now you just man this piece right here, right? It's good. Right? You're just going to find two numbers and multiply to negative 5. Add to 6, or sorry, 4, right? So then you're like, okay, multiply to negative 5, add to positive 4. You're going to say, okay, that's going to be, well, ignore the negative. I need 1 and 5 to multiply. And then I got to force it to add to 4. So if I make the 5 negative, 1 minus 5 is going to be negative 4. That's not going to work with that. So then I'm like, okay, well, I'll make the 1 negative. Negative 1 plus 5 is going to be 4. So then it works. Right? So then you do the exact same thing. You just write down what you have already. 6 multiplied by p minus 1, p plus 5. That's you done in factored form. You see how that's way easier than what I'll show you tomorrow with the complex trinomials. So you're always checking to do that first. You want to see if there's a relationship between these three terms in terms of is there a number that I could take out of there, or like when we did the completing the square, can I get the number in front of p squared to be 1 so that I can actually do the process? That's the exact same thing. I'm trying to get this number out front to be 1 to make the process way easier. So is there a number that I could pull out of all three of those to get me there? Right. Very good? Do the last one. You guys got homework questions or work questions for the rest of the period. Okay. So, again, I don't know what 7 times 147 is. Right? It's craziness, right? You don't want to sit there and have to figure out those conditions. So let's take the 7 out. How many times does 7 go into 147? 70, 21. Okay. Now you're like, okay, multiply to that, add to that. Let's find those conditions. Multiply to negative 21, add to 4. What are the numbers? 1 to 21, not going to work because it's never going to add the 4. 2 doesn't go into 21. 3 times 7. 3 times 7 gives me 21. That looks like it can add the 4 too. How am I going to make that work? 7 minus 3 gives me positive 4. Right? That's it. That's all there is to it. So we have one more thing to do with these things afterward, right? Which I'll show you after we do the other two kinds of factoring. Right? This might be a little bit shorter than the last unit. I only have 7 or 8 lessons in this one. Okay, any questions? Nothing? That's man method. Okay, so you just get to find the two multiples, find the adding, okay? And that's it.